Hello, everyone. Welcome to the AMT Tech Trends podcast, where we discuss the latest manufacturing technology research and news. Today's episode is sponsored by Modern Machine Shop Made in the USA podcast. I'm the director of New Year's resolutions, Benjamin Moses, and I'm here with
Stephen Lamarca, AMT's technology analyst.
Steve. How you doing? The start of February.
How's the gym looking for New Year's resolutions?
Meh.
Apparently, there's a lot of TikTokers who are accusing random people of staring at them. But, we won't get into that. We're not about that. We're about the technology.
We've got some future plans that I want to talk about. You're talking about wedding stuff. And
Oh, man. Okay.
Wedding band. I want to know more about your experience.
So, future, sure. Plans, not so much.
Okay.
We have absolutely nothing planned other than that we're getting the rings taken care of now.
Sure.
And fortunately, one of our colleagues, Rob, for whatever reason, I think he threw a ring at me to pick on me or something. He took his wedding band off and threw it at me as if he was divorcing me.
That's dangerous, by the way. I would never do that for my life.
So, but anyway, for whatever reason, I decided to put it on, and holy cow, it's a perfect fit. And anyway, that got me into. My fiance Melissa is like, will you I sent her the wedding band that I want.
Sure.
Because it looked really cool.
You want to tell me about that now or later?
I'll get into that.
Okay.
But I send her, I want this. Order this for me now. It's like, you have to find out your size, dum-dum. And it's like, oh, okay. By chance, Rob threw his wedding band at me. I put it on like an idiot and was like, oh my, this is a perfect fit.
Right.
What size are you? And he's like, 10.5. I'll bring in a bunch of other ones that you can try too. It's like, whoa, I don't want I don't want a hand-me-down wedding band, but he did anyway, and I got the Mitutoyo calipers out and whatnot. And anyway, found out I'm 10.5.
Okay.
Took all that information back to Melissa. We spec'd out the ring. I want a simple wedding band, no engravings or no stupid gemstones or anything, whatever. It's not stupid. If you have a gemstone with a wedding band with gemstones, it's great. Good for you. But a simple rounded wedding band, but I wanted a really cool material, and I saw this stuff on Instagram, believe it or not, called Timascus, titanium Damascus.
Nice.
And they just there's multiple layers of titanium folded over,
right.
The way you'd make Damascus. But because it's titanium and titanium under heat blues really beautifully,
right.
And it's lightweight and comfortable. But because it blues when you heat it, and there's multiple layers of titanium that blue differently under the same amount of heat, it makes this really cool light blue to deep purple tiger stripe pattern.
Yep.
And it's a little. Melissa did accuse me of picking out a tie-dye wedding band, but it looks really cool, and I thought it was sick. And titanium's lightweight, so it's not going to feel like wearing much. And got it spec'd out and everything. But anyway, gave her the information. She ordered the band, and the company that she ordered from is great. It's like they've done this before. And they're like, okay, you say you're this size, and this doesn't slow down the ordering or production process at all, which is really cool. They get into the production on the company told us everything about how they're made and whatnot. So I got to see a lot of lathe work. That was sick.
Yep.
But they were like, it's not going to slow down production at all. But in the meantime, we're going to ship you a sizing kit.
Cool.
Because it's something 85% of people. I pulled that percentage out of my bum.
Some very high percentage.
But it's a very high percentage of people that order wedding bands buy the wrong size.
Sure. Yeah.
And so in the 2 weeks that it takes to make this wedding band for you, you will receive within the next couple of days a sizing kit, and it will have every quarter size around the size that you think you are.
Okay.
And sure enough, I thought I was a 10.5. I even, when Rob brought in his rings, all of his 10.5s were different sizes, by the way, because I took the Mitutoyo calipers to them. And we're talking within 0.05 millimeters of each other. Sure. And it made a difference, though.
Oh, yeah. Well, some things contact your skin every little bit.
Yeah.
Matters.
And, but anyway, the company sends, all these quarter sizes around the size. Sure enough, I thought I was a 10.5 or 10.5. 10.75
Wow.
is the most comfortable so far. Good. And so I'm wearing my training wheels right now. This isn't it. This is just aluminum.
Sure.
But like it's got like the comfort bevel on the inside. Like they milled it all nicely or turned it all nicely. It's really comfortable. It just looks like garbage because it's not the real thing.
I'm excited to see that. I do like oxidized titanium.
Yeah, it's pretty. Especially on motorcycle exhausts.
Exhaust. Pagani has an amazing exhaust. I just love their process and how they keep their name imprinted on it. It's cool. And speaking of wedding bands, I was doing some yard work and did some stuff outdoors over the weekend. And I normally don't wear any accessories when I'm doing that type of stuff. But for some reason, I just came back from Amelia's swim practice. I was like, I'm going to get some wood for the fire pit later. We got some woods in the backyard. I'm just going to go drag some out, cut it with a circular saw, get it prepped for the fire pit. I put my gloves on, just working gloves because it wasn't super cold. Did the stuff, and I came back inside, washed my hands, and I noticed right away, like I always notice my wedding ring on. Like, it's never comfortable for me. As soon as I get home, I take it off. Both my wife and I are like,
gotcha.
We don't need this because we don't need to tell people we're married because we're at home. So
there's no appearance to keep up.
Yeah. First of all, no one's going to approach me anyway, but when I get home, I take off the wedding because to your point, this is a heavier metal and I do feel it on. It's a good cut, but I always feel it on. But so when I got home, came back in, went to wash my hand and I looked down. That's strange. I thought I had a wedding band on.
Uh-oh.
I went back to my bedroom where I always put my wedding band. Wasn't there.
Uh-oh.
So I was panicking because I was in the woods dragging up pieces of wood. And I thought I wore my gloves the whole time, but one of our bird feeders fell and I was dragging that back out and I wasn't wearing my gloves. Like, did I drop my ring in the woods? Which is literally the worst place. If I dropped it there, there's no point getting it back.
Yeah.
Luckily, I looked around, kind of rummaging around, did a 2-minute search in the woods. Like, there's no way I'm going to find this. I gave up. I thought, what if it's in my glove? So I checked the glove. Wait a second. Let me dig around. Luckily, it was in the glove. So I took the glove off.
No way. It came off with the glove.
So.
Wow.
Thank God.
I was going to think it's like in your pocket or something.
I checked all my. That's what I thought. I thought I took it off when I washed my hands. It left in the pocket. I was like, nope.
That's terrifying.
It's very terrifying.
I'm going to have to make sure I check my motorcycle gloves every time I ride with a wedding band on.
And it's actually nice that you have that aluminum test ring.
Yeah.
So when I go to the gun range or when I do any type of...
you bring a beater.
You could wear your beater. Because I don't wear my wedding band when I go to the range. Because when I used to go on the shop floor and do work on the floor, I used to take all my watch and jewelry off to prevent it from getting scratched. So, Steve?
I don't think beater and wedding should be used in the same conversation.
Unless you're drinking.
Oh, my God.
Can you tell us about our sponsor today?
Our sponsor is the Modern Machine Shop Made in the USA podcast. Tune in for Modern Machine Shop's Made in the USA podcast to explore manufacturing issues faced by companies making an intentional choice to manufacture in the U.S. Featuring commentary from OEM leaders, Made in the USA blends its nearly century-long expertise with a unique audio storytelling experience to shine a spotlight on the past, present, future of American manufacturing. Find Made in the USA on Apple Podcasts, Spotify, and all major podcast platforms. Follow Modern Machine Shop on Twitter, Facebook, and LinkedIn.
Thanks, Steve. I want to get into some articles today.
Yes, sir.
We got a bunch. The first one I want to talk about automation. Last time we talked about automating programming for robotic arms.
Right.
Getting to a streamlined process. Here we've got an article from Automation World talking about what I would call redeployment of equipment. I mean, you could also talk about the initial deployment, but if you're in a smaller factory or a factory where they're doing high number of part numbers but low volume, you have a constant changeover of parts, right? So you're constantly changing from a square to a round or things like that. So to be able to redeploy your robotic arm to either new situations or new parts is fairly important, especially when we look at like job shops or contract manufacturing, right? So there's an interesting article covering a new technology from OnRobot, and I'll read you a quick summary. So users only have to scan the QR code on the module to securely connect to the OnRobot's cloud system, which can then detect all robotic components in the work cell, the robot as well as its end-of-arm tooling. And then other components in the work cell are added in the software environment through intuitive software interface. So what they're saying is, one, using their end of arm tooling and being able to connect through their cloud platform,
Okay.
they know what the end of arm tooling is. So getting to a simulation or a digital representation of the end of arm tooling, that's
So this is
super
an
fast.
on-robot product.
right.
Is it an end effector that they just plug in
Right,
and
yes.
use it as you'd normally use your end effector for, or end of arm tooling
Yep.
for? But the end of arm tooling also communicates with your computer system
Right.
and tells you everything that's connected to it.
Yes. Yep. So,
Wow.
and then they also allow the ability to define the robotic tool, the tool path, and what they're doing is also, instead of issuing poses and specific positions, they're saying, don't do that. Tell what's the objects that you want to pick up and the place, and the path will automatically define itself.
Wow.
So similar to this conversation we had past couple episodes of, there probably isn't the need to say this pose needs to occur, as in all the joints need to go through this orientation. From the end user perspective, they're saying, no, I would like you to just tell me where you want to be, and I know roughly what else is in the cell. Now there's some things in play here, like
Right.
what is in the cell.
What was it called last episode? It was called voxel reservation.
Voxel
right?
reservation.
Wow.
So very similar. Also, when you're designing the cell or the digital environment, right, you're defining what's in the cell. So that's a very good starting point, of course. And then you have the real-time data that's going along with that and all the different scenarios. So not just this, but all the different areas. So the big takeaway is, and we've been talking about this for quite a while, is
Sure.
the need for automation and the ease of implementation for
Yes.
automation. So
Yeah.
not only are we seeing the costs come down, but the ability to say, we don't need a roboticist to get a robotic arm on the floor
Yeah.
anymore. Now, there's significant value in integrators and subject matter experts in robots, as in help us define what the correct arm we need, maybe help us define what end of arm tooling we need or capability. But in terms of, I've got a robotic arm that's been working here, and now I need to change it to either another cell or move it or change the part that it's picking up, that can occur faster and more frequently. So the return on
Right.
investment is skyrocketing now because
Yeah.
of ease of implementation.
Man, the accessibility of automation
Yeah.
is not only is it really impressive where it is now, but like it's almost hard to believe how much better it's getting.
Right.
But that being said, On Robot's doing a great job
Yeah.
with all these innovations, and they are becoming a staple, like a household brand name
Sure.
for end of arm tooling. Which probably works against their accessibility, because if they're becoming like the name brand for
Sure,
end of arm tooling, they're charging a lot. So
Maybe.
we'll see. I'm still going to fanboy over them.
Sure. You got an article on additive in the fashion industry.
Yes,
Tell me more.
Dior.
Yes.
Dior. So we're used to the Adidas working with carbon to make their soles of some of their shoes. Well, Dior was like, let's print as much of the shoe as we can.
Sure.
And so Dior released two, I would say, concept shoes.
Okay.
Because I don't think you can buy them yet. They released a Derby and a boot that I originally thought was a Chelsea because of their lattice structure, that the shoes are printed in.
Sure.
At first, when I saw it, I was like, "Oh wow, they just made the entire thing out of like elastic."
Okay.
But which is, a Chelsea boot is typically a leather boot that has elastic on the side, so you can slip it in on and off.
Okay.
But with this, because they're trying to print as much of the boot as possible, the entire thing is a lattice structure.
Nice.
So it actually looks more like an Ugg boot.
Okay.
But it's still a totally novel design. And the other shoe was a Derby.
Yep.
And I did notice there were certain components of the shoes that were not printed. Like they can only print so much. And it was really cool because they included pictures of like the raw near net shape part coming out of the printer.
Sure.
I'm pretty sure. I think it's nylon. It's definitely polymer. Our team here that knows additive
Right.
was able to do some detective work and determine that the rich color of black that these boots are printed in, and they said, like, the only like material brand that can make that rich color of black in either polyurethane or nylon,
Sure.
I think, which is a common material. It had to be nylon because polyurethane would make sense for a sole, but they're not printing the sole.
Right.
So if it's nylon, there's only one company that can make the material out of with that rich color of black.
Okay.
And this is a big one, SLS, selective laser sintering.
Okay.
For polymer.
That's what they used. Yeah.
So we're used to laser powder bed fusion for
Right.
SLS, which is inappropriately marked. Well, not inappropriately. It still follows the standard that Jason Jones sent us with the the diagram and everything.
Sure.
But if you want to be more specific and in detail about SLS, is typically polymers, and there's very few SLS machines and brands, namely just one, that can use this material. And there's only one brand of material supplier that makes this color black. So it was really cool watching them do their detective work to determine who was making this, who Dior was using to make this, which was cool. But like the other stuff, the sole's not 3D printed. That's clearly injection molded. And then there was other stuff that's leather or patent leather, like the tongue, the eyelets for the derby, and the tongue, of course, and the welt around the soles of the shoes. That was all leather stuff that was probably stitched on after the fact. But, with additive, there's always a lot of post-processing. But it's just cool seeing this.
I do appreciate, additive in clothing and fashion's been going on for a little bit, and I do like the mixed material, so they kind of understand the boundaries of where additive can push them, but also, like you mentioned, the soles, they're probably manufactured in mass assembly, right? So that's
they do print the midsole. Like the midsole has a lattice, like just like the Adidas carbon 3D shoe.
But the contact with the actual ground,
but the
itself,
actual bottom sole,
So that's one thing I do like to see in additive is not just the random exploration, but companies and end users understand you probably don't need the whole thing printed. There's limitations at this point, particularly. Get to a state where you can do a portion of it and then attach the other things as needed. And to your point, additive is an entire process. It's not just 3D printing. It's you prepping the material, growing it, post-processing, and then final assembly.
Additives. So like a lot of people, I was one of them, thought that, additive has this huge advantage over subtractive or traditional manufacturing, whatever you want to call it, material removal.
Sure.
In that, with material mover, with like CNC machining or turning, all of the setup has to be done in advance.
Right.
And then it makes the part and the part's done.
Right.
Additive, nope. You're off to the races right away.
Right.
Click print. I know Tim hates it when I say that, but just click print and it goes. And then when it says it's done, then you open the door to a big dusty chamber, and now you got to move it to you got to brush it off and maybe bake it or something like that. And
there's a whole process.
But what you said, I'm glad you said. I forgot what you
limitations.
said. No
boundaries.
I totally lost my train.
All right, let's move on then.
We're gonna have to cut that.
We got a couple more on a combination of computational capability, fluid design, and sustainability. So Airbus, massive aerospace company, Airbus or Boeing, not too many options there. Airbus selects Altair SimSolid in Zero E Sustainability Aircraft Initiative. So Airbus from the OEM side is driving more sustainable designs of the aircraft, both on the fuselage, engines, everything, right? So what they're looking at is improving their computational fluid design, CFD, to help predict more sustainable designs. So one of the limitations we've seen, and this is where the benefit of additive is reaping the rewards of this, is fluid design is very, very difficult. It's very computational intense. So there's been limitations for the past bunch of years on computer hardware, right? Basically, you're simulating particles or every molecule of gas as you push it through something, right? So if you can imagine tons and tons of elements that you've got to represent and determine pressure drop, determine temperature gradients, there's a lot of variables involved in that process. And as we've seen, as we talked about the GPU markets and their effect, and as new GPUs have been released, new CPUs, and the ability to how we use those technologies for computational design has changed radically in the past couple of years. You know, being able to push, when I was a wee little design guy, everything had to be done fairly local, right? So my capability was whatever RAM I had on my computer, whatever CPU I had on my computer. But now we're seeing the ability to design semi-local, but then push your design back to the server farm to scale up to, I can run over 1,000 CPUs and terabytes of RAM if I need to. So that ability allows for incredibly complex CFD models that will allow us to come up with some very, very radical designs. Some of the stuff you'll see at the fairly short term are like on drones, drones and like propellers for boats. There's a lot of turbulence that comes off of those type of blades, and there's a very notable audio signature.
Yeah.
For especially drones.
Yeah, especially drones.
So what you'll see is a lot of, instead of the blade designs, you'll go to a toroidal design. So it's connected, and it's fairly interesting to actually see that and see if that actually works. But if there's a lot of the turbulence comes from the tip of the blades. So in a toroidal design, there's no tip because it's all connected. So it's very fascinating to see, the process they got to that iteration, and then for them to verify that it works, and it actually produces enough lift for the aircraft.
Yeah.
So that's the type of iterations we're probably going to see is, on the consumer level, fairly radical designs and what we see for blades and moving air. And probably fans, I'm sure Dyson's got an interesting thing coming out soon too.
Dyson.
But that'll transition to, aircraft in the next
Listen,
iteration.
Dyson is a liar. They say they have that bladeless fan. It was probably a month in before the jig was up. It's not a bladeless fan.
They moved the blade.
They made a suppressor for a fan.
Big fan of suppressors.
Big fan of suppressors. Don't get me wrong. But it's like,
speaking of people who use suppressors, Steve, you've got someone that pulled the wool over AI's eyes.
yeah, okay. So last week's tech report, I put in a video at the very end. Well, I put in two videos. Sure. One was like a almost 45-minute video of like a Corvette factory tour.
Right.
But the second video, I think some people may have glossed over because I put it at the very end.
Right.
Because I out of a fear that somebody was like, how may give me some negative feedback. I'm like, how is this manufacturing related? But hear me out. AI is a big topic in the news as of late, especially with ChatGPT and all the fear that and all the hubbub that ChatGPT is causing. I love OpenAI for one, but anyway, we can get into that later. There's a lot of AI in the news, and long before ChatGPT was a major topic in the news, manufacturing industry has been utilizing and trying to utilize AI for quite some time now. Right. I mean, just talk to Autodesk. And I'd be like, we've been using it for the past 20 years or something like that,
I mean, basic vision systems are using a lot of machine learning to object recognition and things like that.
Absolutely. And they're only getting better. Right. And OpenAI would probably say, yeah, we've been implementing this. These programs were written 20 years ago. Right. It's just taken them this long to mature because it's an artificial intelligence. It needs to grow up and mature and learn how to do things. But anyway, DARPA. Mm-hmm. There's a book coming out this month that DARPA was working on an AI-powered, an AI-driven AMR to be employed by the military.
Sure.
And these little four-wheeled autonomous mobile robots would follow soldiers into a combat zone and help force multiply the fire team's situational awareness.
Yeah.
Like help scan the environment for them and notify them if there's anything out of the ordinary that a human might miss, that the human soldiers might miss. And naturally, before you send something expensive and that required a lot of, state-of-the-art technology behind, into a war zone, even though that's a great way to field test something. Naturally, you want to test it in a controlled environment first, because you also don't want such technology to be captured. So you test it in a friendly area.
Right.
And DARPA decided to test this AI recognition system that is driven with an AMR that's driven by the AI as well. Wanted to test it up against a squad of Marines.
Sure. And the goal of it is the
goal,
AMR would detect the object
yes.
or detect humans, right?
Yes, yes. The AMR, the Marines were told that you're going to start 1,000 feet away from the robot.
1,000 feet or 1,000 yards?
1,000 yards,
Yep.
sorry.
So fairly far away.
1,000 yards away from, literally 3 times what I said. 1,000 yards away from the robot,
Yep.
and you have to sneak up to the robot without it detecting you and physically touch
Right.
the robot.
So a game similar to Clear and Present Danger when
Clear and
Chavez
Present
had
Danger.
to sneak up on the
And
trainer.
the robot has been programmed and learned to recognize, people moving,
Yep.
people hiding, like crouched or prone, and like look for snipers, look for any sort of like human movement.
Right.
And the Marines were told this, and clearly, like with what happens next, they clearly thought, okay, we just don't have to act like normal humans.
Or be a Marine.
So the first 2 or 3 Marines charged the robot right away, but by doing cartwheels. 1,000 yards of cartwheels all the way up to a robot.
That's a
If there's
long-
anybody that can do it, forget
Marine
the
game.
gymnasts that go to the Olympics. Marines can do it. They cartwheel all the way up to the robot, touch the robot, never even had anything. I guess it thought they were tumbleweeds or something. I don't know.
Who
I don't
knows?
know.
Who knows?
But it's helping the AI.
Sure.
Helping the AI learn
Yeah,
and develop. The next Marine that went into some nearby woods,
Right.
ripped all of like the limbs and foliage off of a fir tree,
Okay.
and put it on his uniform,
Yep.
and I quote, proceeded to walk towards the Marine or the robot like a fir tree.
Like a fir tree.
Apparently fir trees walk. I haven't seen it before, but the Marines know how they walk. Totally undetected,
Yep.
touched the robot.
Wow.
Another failure.
Yep.
And the last 2 or 3 Marines found a large empty cardboard box
Yep.
nearby, put the cardboard box over themselves, and snuck up to the robot and touched it. And the engineers and observers wrote down in their notes and their observations that they could audibly hear the Marines giggling as they were sneaking up like Solid Snake and Metal Gear Solid to this robot and touch it. The robot, the AI system in the robot was a total failure, and the engineers have to go back to the drawing board because the Marines got them. So if anybody's worried about ChatGPT, just send the Marines.
That is very entertaining, and it's cool to see that DARPA. You should always look at DARPA's challenges. They're amazing, like the type of stuff that they put in place and the failures through some of these challenges are fantastic.
And you have to make sure you give DARPA credit,
Right.
because they fail a lot,
Yeah.
but they learn from their failures, and they fail because they're the first ones doing it.
Yeah, correct. And this also brings
Like,
up,
you're never going to do anything successfully the first time. Rarely are you going to succeed at something the first time.
and it's interesting. You brought up the kind of concepts that are in the training model for that type of AI or machine learning application, and all you have to do is do something outside of the training set.
Yeah.
So obviously they're very creative. Marines are very creative and said these are the boundaries which it's set up, and go around those boundaries. And I thought that's a very interesting example.
I'm about to get really nerdy.
Okay.
Because my mom was a Trekkie.
Okay.
And I remember when she showed me some of the episodes of like the Borg.
Yep.
Like you'll always find a way to defeat the Borg once.
Right.
And you'll never be able to use that way to defeat it again because they're AI.
Yeah.
And
that's a good example. It's the way to bring it back
Star
to
Trek, dude, Star Trek saw all of this first.
Where can they find more info about us?
amtonline.org/resources. Hit all the buttons.
Thanks, Steve.
Bye, everybody.
Bye.